So again, good evening to all participants. I have sent this Excel sheet, final data sheet 28/10/2020 on WhatsApp. So before enter or import this Excel sheet in your SPSS, and second sheet is final data sheet ANOVA. If you have time, then you can enter this. But first, you please enter this sheet 28/10/2020. So I'm going to start with the because yesterday we have left these things. So I thought that I should complete first because it is necessary not to complete hurry, but to understand by the participant, it is very necessary. So we have left, I think, parametric test. I have given demo on independent t-test and dependent t-test. Then today we will discuss one way ANOVA and then non-parametric test, Mann, Whitney, Wilcoxon, and Kruskal valleys. So you have to remember this next slide. Parametric versus non-parametric test. Always, whenever you are going to analyze your data, you have to have this slide in your mind. What are my independent variable and type of independent variable? This is in two groups, same group, more than two groups, quantitative independent, or one group with the repeated measures. And what are your dependent variable? Qualitative, categorical, quantitative, which type of quantitative, which type of qualitative? If qualitative, nominal or ordinal. If quantitative, ordinal, interval or ratio, then we have to decide which test we have to apply. We have already discussed yesterday about this. And please remember this, if dependent variable is ordinal in number, for example, NRS Penn scale or modified Rankine scale, etc., then no need to check normalcy. Directly go to non-parametric test. This is preferred by most of the journals. Then you have to, if your dependent variable is ordinal in number, no need to go for mean and median, mean and standard deviation. You have to go for median and interquartile range with non-parametric test. So let's have fun with SPSS. I have conducted this study. This all is hypothetical, okay? A randomized clinical control trial to assess the effect of treatment A on the quality of life of neurosurgical patients. And my primary objective is to assess the effect of treatment A on the quality of life of neurosurgical patients. And secondary objective or objectives to assess the effect of treatment A on vision or functional vision or hormonal level among neurosurgical patients, and to assess the effect of treatment A on functional outcome, that is a modified Rankine scale, MRS, and to assess the effect of treatment A on patient's survival. My methodology is I have randomly selected 120 patients, 60 in each group, treatment group or control group. And then I did 3 months follow up. And what I want to see, I want to see, is there any significant difference of BMI between males and females? Okay, just like I want to see this BMI between males and females. Then you have to think what is dependent variable and what is independent variable. So BMI is a dependent variable, and male and female, that is a gender. It's a categorical variable or qualitative variable, nominal type of level of measurements. It has two like category. So it's called binary variable, binary. And BMI is a continuous variable, quantitative variable. And there are two groups, independent groups. So what test I have to use? I have to follow this. Okay, there are two independent groups and this one. Here two independent group, categorical male and female, and that is a BMI is my dependent variable, that is a quantitative in nature. So I have to check normalcy. If BMI follow normal distribution, I have to use this independent t-test. Otherwise I have to go Mann-Whitney. Okay, Mann-Whitney. So suppose I have checked BMI, normal distribution of BMI, and that is normally distributed. Then I have to go for independent t-test. Next, is there any significant difference? I want to see, is there any significant difference of 3 months WHO quality of life total score of the males and females according to gender? So male and female, again, there is a two groups, and WHO quality of life again is a quantitative variables. Then again, t-test if WHO quality of life is a follow normal distribution. If not normal distribution, that is a I have to use a Mann-Whitney test. Is there any significant change in WHO quality of life total score from baseline to 3 months follow-up? If there is any improvement, decrease, whatever, in treatment group as well as in control group, within the group, I want to check. Or is there any significant change in WHO quality of life total score from baseline to 3 month follow-up according to their gender? Again, gender. So I have to use this t-test. Is there any, and then you can see here in number third, is there any significant change in WHO quality of life from baseline to 3 month follow-up? It means this is baseline to 3 month follow-up in treatment group as well as in control group. So baseline to 3 month follow-up, I have to see, okay, this is before and after, and I want to check within group, treatment group separate and control group separate. WHO is quantitative and follow normal distribution. I have to use dependent patty test. Otherwise, I have to go Wilcoxon signed rank test. Is there any significant improvement of functional outcome, MRS, at 3 months in treatment group compared to control group? So you have to know what is like a functional outcome about, about what is functional outcome. So I told you that MRS or functional outcome is a ordinal scale. In next slide, you have to know about what is MRS. And this like number is given 0 to 6. 0 means no symptoms. And 1 is no significant disability, able to carry out all usable activity. And 2 is slight disability. 3 moderate, 4 moderate to severe, 6 severe disability, and 5 severe disability, and 6 death. So it means 0 is no symptom to 6 is a death. The worsening is increasing. With increasing, the number is increasing, the worsening is increasing in the patient. So it's a ordinal numerical scale. Modified Rankine scale is a ordinal numerical scale, and then you have to follow this. Not if dependent variable is ordinal numerical scale like modified Rankine scale, no need to check normalcy, directly go to non-parametric test. So which non-parametric I have to decide? I have treatment group, what I have written here. Is there any significant improvement of functional outcome at 3 month in treatment group compared to control group? So there are how many groups? There are two groups. So two groups, independent groups, and my outcome variable is ordinal number, ordinal in number. Okay. So which test I prefer? Okay, this is two independent group and this is our ordinal number. Then I have to go for Mann-Whitney test. So I have to use Mann-Whitney test for this. And again, is there any significant difference of 3 months WHO quality of total score is per religion of subjects? So what is the independent variable? Religion. And what is dependent variable? 3 months quality of life total score. And how many religions? I think I have to see in data sheet how many religions patient participants we have, subjects we have. Okay. And then is there any significant improvement in survival of, oh, there is a problem here, sorry. Patient a 3 months due to treatment. So we will discuss in tomorrow about this. Tomorrow, next day, day after tomorrow. So we have discussed. Then start. I have to check my Excel sheet. Okay, I have entered data in my Excel sheet. 28 and 2020. This I have to click here. I have to see, okay, this is a serial number here. Okay, it's okay. Then in first row, I have to have variable number, variable names. Okay, variable names I have. Okay, it's okay, very good. And from second row, I have to have the observations, and then I can see all the things. Okay, very good. Total 120 patients. Okay, it's okay, very good. Now I have to proceed for this. Then I have to cross it. I have to open my SPSS file. Then today I want to show third way of how to enter Excel data in SPSS. Third way. So I have to like minimize like this. Excel sheet, SPSS sheet minimize, and this where is my data sheet? I have to minimize both things. Window, I have to minimize. I have to click this sheet and I have to drag and drop this sheet into SPSS. So this is drag and this is drop. So you can see there is a arrow move, then you have to leave it. Okay, once again, you have to click this sheet, right click your pad, select it, and you know that how to drag any file, and then you have to okay, this is a move, and then you can leave it, then wait for some time. Okay, it's it. This window, one window is pop up, and you have to check, okay, this is sheet 1. You have to check 3 box, read variable names, percentage of value, and login, ignore hidden rows and columns. So you have to check 3 box. It is mandatory to check all these 3 box, and then you have to click OK. Then it's a output window, and my data sheet automatically imported in a SPSS sheet. So it's a very third way of how to enter data in SPS. It's a very simple shortcut way. Then I have to, because the group is in treatment and control, then I have to give coding. And please remember, if you forget these coding, you have to make one coding sheet in Excel. So like, for example, I want to show, this is Excel sheet. This is Excel sheet. And this is sheet 1 here. Sheet 1 here left below, and this is sheet 2. So you can make it coding sheet. For example, code like group coding treatment is I have given 1, and control I have given 2. So you never forget it. Please save it so you never forget. If gender, so I want to give female and male. So please give like, it's my routine that I give code female to 0 and male to 1, because ladies first. So I give female 0 and male 1. You can give 1 or 2, but I prefer, please give 0 or 1 for gender. If you want to make the female is a 0, you can, but I prefer female is a 0 because ladies first. Now, so this is a coding sheet, second sheet, and this is a data sheet. So this is, and I have, because I have to save, so these coding sheet automatically saved. So cannot forget all there. If I forget, then I can search it out. Now I want to like give group coding. I want to make treatment as 1 and control as 2. So if I go in like transform, yesterday I like told you that if I give like click here transform, want to give coding, so I click here transform, then record into different variable. Please prefer record into different variable. So if I click here, then because I have to give group coding, I want to code group, so I have to click here and then on group, and then this is arrow, okay, horizontal arrow to right side, I have to click here. Then this is a output variable on right side of this dialog box. So name of output variable I have to give separate different name. So click here group code, group underscore code, okay. Then click here change, this is change button, I have to click here. Then this group code will come here as a output variable. Then old and new values, click here, value here old value, then I have to give treatment, treatment new value 1, then add here, click add, and this automatically come here old new treatment 1. Then control, I have to click here control old value control, then I want to give code 2 as control, then I have to click new value in value 2, then I have to add, and then I click continue and okay. So I know that where I can find this group code at the end of this. But here is a group code and I want, because this is mostly use variable. I don't want like on at the end. I want it in like just beside this group. Okay, just beside this group. So it's okay for me. I can like do, it's easy for me. Okay, so group and group code. So what I have to do, second option, I want to like, it's a shortcut method, how to give code. And usually, generally, I use this shortcut method, never use this like transform and record into different variable. So first of all, I want to delete it. If you want to delete it, group code, you have to click on group code here. This group code has been selected. Then you have to click right on the pad, right click. Then you have to click on clear. Then it's automatically gone. Okay. Then I don't want group at the end. I want group just near this like group code, just near this group. So what I have to do, I have to click this as nearby variable on age. Just click, and this like variable or column highlighted. Then I have to click pad right side pad. I have to click on pad right side. Then I have to insert variable. I have to click insert variable. So please click on this insert variable. This one more column has come variable 1, where 0001. Then I want to give treatment as 1. So what I have to do, I just click 1 here, 1, then click here, then again click on this 1 and control or C, that is a copy. I want to copy it. So control or C on your keyboard, you have to press both control and C. So this 1 automatically copy. Then I want to paste this 1 up to treatment group up to here. So what I have to do? Nothing. I have already copied it. Then click here this arrow on one and then press shift and down arrow and up to treatment group. Then click control or V, that paste. So automatically came here. Again, I want to give control as 2. So I have to like give 2 here, then click just below or wherever you want to click, no need to go on below. Then you have to click again on 2 and then control and C and then shift and down arrow. And then I want to give 2 up to here, then control and V. Automatically came here and it's just close to this group. I need this. If there is any mistake, error, then I can check easily. Now I want to give this variable name as a group code. So what I have to do? I have to double click this variable. So I want to double click. Automatically this come here. Then I can give group code. Okay. Now again, I want to give value to because I have given 1 or 2, but I want to decode it. First we code it, then now I want to decode it. So what I have to do? I have to click value here. And because I know that I have given code as 1 and 2. So 1, 4, I have to press like this dialog box come value label. And then I have, and in value label, in value box, front of value, I have to click 1. Then label is treatment, T-R-E-A-T, treat only. There is no need to treatment. You have to write down complete. Then click on add. Then 2, I have to like give control as a 2. So value 2, label as a control. Then I have to click add and OK. Now I have, and I have to click here on 4 in front of group code. Again, I can reach where is my data sheet group code. Automatically I have reached. And then this is serial number, patient code, group and group code. Then I know that this is age is a like a continuous variable, quantitative variable. It's come in a string variable. There is a mistake. So what I have to do? I have to just double click here. And this is age is coming here in variable view. Then click here string. And then this is a pop-up window is variable type pop-up window is opened. Then I have to click on numerical. Then width is 3 decimal. There is no need of decimal for age. Then I have to click OK button here. And I have to change this measure. The measure of age is a scale. So I have to click on in front of nominal. There is a like arrow. And then I have to click on scale. And this is a scale variable. Now click on data view. Again, data view. So you will get this. And my number 1, male and female, I want to see that is there any significant difference of BMI between male and female. So what test I have used? I have to use independent t-test. So before independent t-test, I don't have BMI. It's only weight or height. I don't have BMI, but I know that the formula of BMI. And with this weight and height, I can calculate BMI. So again, I will compute one more variable for you, that is a BMI. And how to compute BMI? I know the formula of BMI is kg per meter square. Per meter square. Weight in kg per height in meter square. Weight in kg divided by height in meter square. But I have height in centimeter. So I have to convert it into meter. So what I have to do? I have to divide each height by 100. So it comes automatically in a meter. So what I have to do, because okay, so I want to create here, height is centimeter, I want to create height in meter here. So I have to click here, then right click. On duration of symptoms, I have to click nearby this height centimeter. I have to click here, then right click on page. This window will come, then insert variable. Then I want to write down here on variable name height meter. And this is a height in centimeter. So what I have to do, I have to do like click on this variable view, double click. So automatically I have reached here variable 0002. Then I have to give variable name height meter. Okay, meter, height meter. Then please copy this height meter. Okay, please copy this. So you have to click here and then you have to select this height meter and then control C. You have to press control C. This variable automatically copy. And after that, you have to click this transform and compute variable, because I want to compute height in meter. Click here, and then on target variable I have already copied this because this is my target variable height meter. So control and click here this button on below the target variable in compute variable dialog box. Click like cursor here and then control C. You can write down here, there is no need, but it's like shortcut method, height underscore meter. But you have to remember, if you type here, the spellings are same. Spellings are same. Spelling must be same. Okay. So I want to compute height centimeter into height meter. So this is my independent variable. You can see. So I have to, because I want to change this height centimeter. So I have to click on height centimeter and then this arrow. Okay, right side arrow, I have to click here. This automatically height centimeter come here. Then click on this button. This is a divided by. Okay, this is divided by. Click here on this button. Then type 100. So this height centimeter automatically change into height in meter. Then click OK button. Then there is a pop-up window. This is a change existing variable. Why? Because we have already given height meter. So, and we have like copy paste here height meter, and we want that this height meter comes in this. So I have to we have to click here. Okay, change existing variable. There is no problem. Then we can see in data view, this height comes in a meter. Oh, very good. Then I want to I want to compute a new variable BMI. So height, weight is here, height is in meter here. Then just nearby this height in meter, I want to create a BMI. So again, select it, right click, and then insert variable. I want to be hurry here. Then variable 3. Okay, automatically change in this. So we can change it. Okay, no problem. So I have to double click here. This is variable 3. Give it BMI. And then shift and left arrow, press shift and left arrow. And I selected this BMI and control and C. I copy this BMI. Again, click here transform and compute variable. Then please remove this already targeted variable, control and V BMI. And I have to remove this. Now I have to use formula for formula of BMI. So what I have to do? I have to do shift and bracket first of all, then click on weight, and please bring this weight, transfer this weight to types and labels to numerical expressions. Then click this button divided by or slash, and again because meter square, so like height in meter square, weight in kg divided by height in meter square. So you have to make like you have to bring one column, you have to type one column here, like bracket here, again you have to type bracket here, then you have to click height on meter, and you have to bring this height on meter to numerical expression and multiply by, because square is a multiply by. So shift and 8, you have to press shift and 8, this star will come, otherwise you can take star from here, this is a star button, click here, again you have to type height meter, and you have to click this arrow, again this height multiply by height, it means height meter square. Then you have to first like bring close the bracket, shift and bracket close. So this bracket close for height height square, okay, and like height square, height meter square, and again you have to close this like for weight, so weight for this one, so you have to click one more shift and bracket. So you have to remember how to compute this, there are other method to compute, so and click OK, and then again change existing variable, I want it okay, because I have already given BMI here and BMI here, so okay. Then you can see in your data sheet, in data view, this is a BMI, very good. But you know that this BMI is a continuous variable. So you have to click here because this is a nominal nature. So I have to click, double click here. I have to change this measure because this is a BMI. I have to change this measure. This is a scale type. This is not ordinal. This is a scale. Okay. Now I go for independent t-test. Okay. BMI and gender. There is a difference between BMI and gender. So I have to choose independent t-test. Click on analyze button here. Then compare means, because BMI is a continuous variable. So I have to compute mean or compare means. Then there is an independent sample t-test. Click here. I have already like explained you yesterday. So fast, I want to explain you about this. So because in test variable, your dependent variable is BMI. So I have to click on BMI here in this left side box, and then click on upper arrow, and this BMI will come here. Then in now like below this test variable, there is a grouping variable, and I want a group code here. Not is group is A, that is a string. So I want this. Okay, so I have to click the, like group code, and then in grouping variable, this arrow, I have to click on this arrow. Then I have to always define for t-test, define group. So I have to click, and then already define 1 and 2. Okay, yesterday we have defined. So continue, and then there is no need of effect size. Okay, so don't want to select it. Then you have to click on OK, final. So this is outcome of, so in treatment group n is to 60, and in control there is a number of patient is 60, mean is 23.30, okay, and in control 22.57, and SD is 7.66 and 7.09. And where is p value? The p value is here. This is a t value 0.538. This is a degree of freedom, and degree of freedom for t-test is n1 minus 1 plus n2 minus 1, that is n1 is a like number of patients in group 1, 60, so 60 minus 1 plus n2 is a number of patients in second group, that is a control that is a 60, so 60 minus 1, so 59 plus 59, that is a 118 degree of freedom. And I told you that yesterday you have to check Levin's test for equality of variance. So this p-value, significant p-value is a 0.674. So you have to choose this equal variance, assumed p-value, and this is p-value significant two-tailed, 0.591. So according to male or female, there is a no significant difference in the BMI, mean BMI of control and treatment. So mean BMI is comparable between treatment and control group. So, okay. Then if I want to see, suppose BMI is not normally distributed, then I have to use independent t-test. Then against independent t-test, I have to use non-parametric test, Mawali kahin ka, that is a Mann-Whitney test. So I have to use Mann-Whitney test. I want to show. So click here, analyze. This is output window. You can click here, no problem. And click here, analyze, and there is a non-parametric test here. And please, and in non-parametric test, you have to go here. This is a small dialog box, and you have to go in legacy dialog. And there is a two independent sample. We know that treatment and control are two independent sample. Okay, so I have to click this independent sample. One sample Kolmogorov Simornov. I don't want it. I want according to my situation. Is there any significant difference of BMI in like treatment or control group? Male female ki jagah mein, like in the place of male and female, I have taken like treatment and control. So just for demo. So I have to click this two independent sample. If more than two, I have to use K independent sample. And if like two related sample before and after, then I have to use this. And if there is a k-related sample, means multiple follow-up, then I have to click here. So I have to click on two independent sample. Then this dialog box will come, pop-up window will come. Then I know that you can see here in this two independent sample test, and this is on below this test type, you can see this is Mann-Whitney U, and you have already clicked or default click here. Okay, so no need to click it. And you can see all the string variable has gone. There is no any string variable, only scale variable and nominal variable are here. But string variable, ABCD variable, they have gone from here. So what I have to do, I want to check BMI. So I have to click this BMI here, and then this is arrow, same as a t-test, test variable. I have to like bring this BMI, and in grouping variable, where is group code? I have to click group code, and then this, because this time the BMI is not normally distributed. Then I have to click define group, and then I have to give code 1 and 2. I know that 1 and 2. Otherwise, I can refer my Excel sheet. What I have given this code to the treatment and control. I have to click continue, and then OK. You can see here. Please ignore this. There is no need of this. Ignore this. No need of this. You have to click, see this test statistics. This is a Mann-Whitney, non-parametric test, Mann-Whitney test. No need to like see this because there is no need, and no need to write down in your manuscript also. So you have to see, because Mann-Whitney test is depend on rank of the like subjects according to BMI. So rank, this is a rank. Okay, so we have to see this is a asymptotic significant two-tailed. We have to use like two-tailed. So this is p-value 0.365. So there is a comparison between treatment and control. So this is p-value, this is Mann-Whitney U-test value, this is a Z value. No need to write down, only Mann-Whitney you can write down, and p-value you can write down. So you see here that in t-test, when you see this independent sample t-test, so significant is 0.591, and here this is 0.365. So there is some difference in p, like p value in a parametric and non-parametric test on a same variable, treatment and control. control and BMI. So maybe you will get here a significant result in T test. So in main and non-parametric test, you will not get. And vice versa. You get non-significant result here, but you will get significant result here. But you have to provide evidence why you use this test. You have to check normalcy, QQ plot, histogram, and then you have to provide your result. Not only these are the significant in non-parametric tests, they come significant, then you can use. Okay. So I have like explained you, but you have to give with because in a T test default is default in default mean and SD already come. Okay, mean and SD already come. But because in T test we use mean and SD, but in non-parametric test or whatever non-parametric test, we have to use median and IQR. So I'm going to tell you, I'm going to demo on how to calculate median and IQR. So all in SPSS, this is only way to get median and IQR for treatment and control separately. So you have to go in data button, data, this is data, you have to click this data, then you have to click on split file. Whenever you use man-Whitney test and want to get median and IQR, you have to follow this step. So you have to click data, then split file, click here, split file. And because I want separately median and IQR, so I have to organize group, click here, organize group. This is a split file, and right side there are or analyze all cases, don't create group, but I want to create group or compare group. So I have to click on this button, on the circle, then this like arrow highlighted. Then I have to click because I want to separate or split file according to group code, treatment and control. So I have to click on treatment code, then I have to click this arrow, and this group code comes in groups based on, okay, groups based on groups code. Then I have to click OK. This button is here, OK. OK button. Then you can see here sort cases by group, okay. And there is a split file led by group code here. Then simple for median IQR, it's very simple. Click on analyze, descriptive statistics, and then frequency. If you don't split file and you calculate median and IQR of BMI. This is a BMI. I have to click on BMI and then variable. I have to bring this BMI on variable. So I have to click this button. And I don't want this display frequency table for continuous data. So I have to deselect it. Then click here. This is in right side, there is a statistics, chart, format, style, and bootstrap. So I have to click on statistics. And I have to click here, and there is a quartile. Quartile is a median IQR. All the things I can get in quartile. There is no need to, there is in percentile value, there is a quartile. No need to click on median. Why? Okay, I click just median in central tendency. I need only median. If you want minimum, maximum, you can click here, minimum and maximum. This is in dispersion, there is a minimum and maximum. So you have to check these box and click on continue and then click OK. So according to group, you have got treatment. And you know that there are 20 missing. And why these 20 missing comes? Because the data below 120 are missing, dot, 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 dot. We can remove as we removed yesterday. Okay, so treatment, there is a valid case 60. Okay, we know that we have 60 treatment subject and control 60. Very good. This is median 23.05 minimum and maximum, and this is IQR. Again, that 50th is a median. This 50 is equal to median. You can see here. So this is treatment group median is 23.05, IQR is 18.96, and first IQR, first like quartile, and third quartile 75. This is a third quartile, 26.1 and 1. If there is a because we have to use two decimal. So if this one is 5 or above 5, then we have to add 1 here. You have to remember this. And in control group 60, like we can see median is 21 and something, and then this is a minimum and maximum, and this is a percentile in 50th also equal to median, and this is a interquartile range. Then I can use these median and IQR for median Mann-Whitney test. But if you don't split file, so what happened if you don't split file? Suppose I don't split file, click here data, and then click here split, and then analyze all cases. I don't want to split file for to calculate median and IQR for case and like treatment and control. So what happened if I don't split file? Click OK. Then now same process, analyze, descriptive, and sorry, analyze. Oh, ye come. Okay. There is okay. Frequency, click frequency, and then statistics, click here. We have already selected. No, so I will just click OK. We have already selected this BMI. So this BMI will come for 120 patient, not separately for treatment and control. But we want a treatment and control comparison. This is only way to like calculate separately median and IQR for any continuous or ordinal variable, quantitative variable, ordinal variable. For Mann-Whitney test, you have to first split file, and then you have to you have to analyze for, or you have to get descriptive statistics or median. Okay, so this is a t-test and Mann-Whitney test. Now second one is where is second one? Okay, here is there any significant difference BMI between male and female? On the place of male and female, I have used this groups. Now this is there any significant change in WHO quality of total score from baseline to 3-month follow-up in treatment group and in control group? So what this third number question is that we have to check, we have to compare, or we have to assess the change in WHO quality total score from baseline to 3-month in a treatment group separately and in control group separately, means within group. So again we have to first split file, then we can analyze separately within group. So again we have to separate this or split this file. So but I know that in my data sheet, this is my data sheet. Just click here on taskbar, and this is data sheet, and these are the values which are and sorted out. So yeah, these 22 came up. So I want to delete it because these are the like empty cells. So just click on one. So this arrow selected, then shift and down arrow and up to 22. Okay, I have selected. Then please bring your cursor not on the serial SPSS serial number. We have to bring our cursor here and there in SPSS data entry point over there. Then I have to click right on pad and then clear. Okay, so go on. What I have, I want to see that so what I see here, where is my WHO quality of life? Okay, here. This is WHO quality of life. And you see here that it's 4 domains. And I think these are the physical, emotional, social, psychological domains are. But in question, total WHO quality of life. So how we calculate total? It's very simple. You have to compute this variable, because here is a WHO and this is a quantitative variable. Again, it's come string. So there is a like some mistake in SPSS. Sometimes it will come. So what happened? You have to click. I want to change it in a scale type of variable level of measurement. I have to click here, double click, then string here, type here, that is a name of the variable WHO. This is a string. I have to click on string here, then just click on in this window will come, and this is a variable type, and I have to click on numerical because I know that WHO is a numerical, width 2 decimal 0. Okay, very good. Then again on this domain 2 numerical and okay. Then again in type domain 3 numerical and okay. And then again on string numerical and then okay. So you have to, because we have done already this. And again I want to check, this is a 3-month follow-up WHO quality of life. Again this is a string. So same, I have to click on type, then numerical, okay. Then again string numerical, because I have to check numerical. I have to click here in front of string. Then this is a variable type numerical. Okay. Then again string. So I have to change all the numerical, because these are the numerical due to by mistake of SPSS. These come in like a string. So click here on data view. Otherwise you can, because I know that I want to compute one more variable WHO, okay, WHO quality of life, because these are the 4 domains, but I want total quality of life. So what I have to do, I have to create one more variable, and there are different ways to create or add variable in SPSS. So in this, what I have to do, I have to click this is 27 hormone in variable view. No need to go data view. Again, this is another method how to create one more variable. Just click on 27. Okay, this arrow like row is highlighted. Then on pad, laptop pad, you have to like click on write and then insert variable. Click on insert variable. So this variable, and I want to give directly. I want to give total underscore WHO underscore quality of life underscore baseline. I know that this is a baseline. You have to give baseline. Otherwise you will get confused. This is a baseline. And then I told you that you have to select it by, you have to click your cursor here and shift and left arrow, then control and C, paste. Then there is a transform. You have to click here on transform. Then you have to click on compute variable. Click here on compute variable. This window come because we have already compute BMI earlier. So I have to remove this. Then I have to click here and then control and V. The same variable will come here. Then I have to also remove this numerical expressions. Then what I have to do, I have to add 4 variable here. So I want, because this is a baseline, I want to add quality of life. Just click here. I have to do some fast because I have already explained. Then you have to click on plus. Where is plus? This is plus. Very good. Then you have to click on this again, 2, domain 2, then click plus. Don't forget sequence. WHO domain 3, then arrow, then plus, the WHO quality of life domain 4, and whatever you want to which variable you want to add, you can have to repeat this sequence and plus. No need to plus because we have to add only 4. Then click on OK. Same change existing variable. Why this came? I have explained already. You have to click OK, and then you have to see your data table. So you can see here, you can just click on 27, double click, or otherwise you have to click on data view on below this left side. So when you click on data sheet, you see here total quality of life. Suppose this is only just example, okay? So this is total of this. And you can see it's a very good thing. Okay, you can see, okay, everything is okay, very good. No, if you need these 2 decimal, otherwise you can remove. It's very easy process. And now I want to have total WHO quality of life on a third month. So I have to go on third month. So please drag your data sheet. This is a quality of life on third month. Very good. And I'm going to within group. Okay, I have to do within group. I have already done this. Okay, earlier I have to already done this. So string is has gone from here. Then I have to click one more variable, total WHO. So you have to click here. There are different ways, and click paid on right side, and then insert variable. It's come here. Click on this, double click. Otherwise on variable view. So when you click variable view here, left side below, so you have to search. Otherwise, if you double click over there, no need to search because it's automatically come up. So then you have to click here, total. I have to give total WHO QOL, okay, 3 month. Bas, 3 month follow up. Very good. Again, you have to select this and then control C. Same procedure. Compute transform. You have to click on transform. Then compute variable you have to click. And then because you know that you can remove this, control C. Okay, 3 month follow up come. And because this is for other variable, this is the baseline. So I have to remove all these things. Then I have to go below. Where is, okay, this is domain 1. And then I have to, okay, I have to make some hurry. Then click here on domain 2, then this button. And again, I have to press plus. You can press on key like shift and like plus, and again, you can click here plus. So both are same thing. And then domain 3, and then arrow, and then plus. This is plus sign. Then again, WHO quality of like 4, and then arrow. Then it's no need to like plus because all 4 I have entered. Then click OK. And then again, change existing variable. Yes, I permit it. So you can see on data sheet. Okay, if you double click here on WHO total quality of 3 month follow up, you have just double click on 57, you will get it here. Yeah, this one. Yes. Then we have to now analyze within group, change from baseline to 3 month. So I have to before and after, same group, because now I have to divide, I split group. I have to split group. So in treatment group, only in treatment group, within group, baseline to 3 month, and in control group, change in baseline to 3 month. Then I want this p value. In treatment group, separate p value, and in control group, separate p value. So I will get 2 p values separately. Is they significant in treatment group only or in control group from baseline to 3 month. But as a researcher, I want treatment group will get the WHO quality of life will increase statistically significant. In control group, I don't want. But what happened, because this is only just hypothetical data. So what happened, we will see. And how we see, okay, let's have fun with this play with data. I have to click because I have to split file first. So I have to click data and then split file. So click here, split file, and then here click here, organize output by group. When you only calculate mean and median, then you can compare group. Otherwise, you have to, if you want to like test separately, like analyze separately, then you have to click organize output by group. So click on this circle, then okay, already group code, very good, and then click OK. Click OK. So this file automatically is splitted. Now within group, from baseline to 3 month, I know that 3 month WHO quality of life increase. I want increase. So what I have to do? 3 months minus baseline. So first I have to click on 3 month. I have to enter 3 month. Then I have to enter baseline. Then 3 month minus baseline I have to get. So click analyze, compare mean, because I know that I have assumed that WHO quality total score is like normally distributed. This is a before and after and one group. Then I have to use this paired t-test. Click here. It's very good. Then all string variable has gone from here. So I have to give group code. Otherwise, if I don't give group code, the only group, the treatment and control in alphabets has gone from here. So I have to give. Now click here first. I have already separated. Okay. So this is a 3 month quality of to total WHO quality of life 3 months. So I have to click on this because I want the change in total quality of life. So I have to take first it. So click this arrow. So this is in variable one. You can say this is a pair one. Come here. Then I have to click total WHO quality of life baseline. Then I have to click here and this will automatically go in variable 2. If I select one more pair, then I have to click here, then it will automatically come in 2. And then automatically the pair increase 3, 4, 5, 6, 7. When whatever you want, you can like automatically increase, not only for 2. Then click, I don't want estimate effect size, just click. Okay, leave it. Then click OK. So OK. And this is your pair 1. Pair 1, this is a total WHO quality lab 3 month, and in which this is a group code treatment. This is a group code treatment, and below this is a control. And where is group code? This is a group code treatment and control. You can see here, this is a mean total quality of life after 3 months. This is before 3 months, and 57 because there is a loss to follow up, something like that. And this is the standard deviation. You can see here standard deviation. You have to take 2 decimal. Please ignore this. No need to this because I will if you want to take this before and after there is a correlation or not, you can take this. No problem. This is R value. This is a P value. But because I will demo on next day about this correlation, then we will discuss again. Then you have to take, this is a mean difference. This is a difference. This is a paired sample t-test. In this table, you can see this is a paired difference. This is a mean difference between 3-month follow-up and baseline. And this is a standard deviation difference. And you can see this is significant to tell. This is a paired t-value. This is a degree of freedom, and in paired t-test degree of freedom is n minus 1. N is 57 minus 1, that is a 56. So this is highly significant. So in treatment group, the quality of life increased highly significant. Mean is itna, at baseline mean is this much, mean and SD is this much, and at third month mean and SD is this much, and the mean difference is this. So it's increased statistically significant. Now control, you can check. This is you have to check paired sample statistics, 3-month mean, and it's here 58. So how degree of freedom? What about degree of freedom? 58 minus 1, that is a 57. Here 57. You can see in paired sample t-test table that is a 57. You just ignore this paired sample correlation. No need. We will discuss later. So this is a mean here. 300, 114, 14, 314. Then standard deviation, you have to take only 2 decimal. This is baseline mean. You can say that it's increasing. So in like WHO quality of life, the mean is increasing. In control group, it's statistically significant or not. You have to check in paired sample test here. Okay. So this is also statistically significant. So this is paired t-test. Suppose this WHO, total WHO quality of life is not normally distributed. So how to use non-parametric test, Wilcoxon test in place of Patty test. So there is no need, because I have already separate split this file. So just go on, click on analyze, and then this is, you have to go in non-parametric. Here is scale forecasting, there is a non-parametric test. Then you have to go in a legacy dialog, and after that there is a two related sample, before and after two related sample. You have to click here. This dialog box will come, pop-up window, same as pad t test. Okay, so first you have to click total WHO quality of life here, click on this, and this will come in test pair 1 variable 1, and then we have to select this total WHO quality of life baseline. You have to click here in this button, then in automatically variable 2, then you have to click on OK. This will come automatically, Wilcoxon signed rank test, automatically Wilcoxon signed rank test. You can see analyze, non-parametric test, legacy dialogues, two related sample. So there is, in test type there is a default is a Wilcoxon signed rank test. Okay, so click here cross, and you can see in treatment group, please don't see this rank, you have to see only just test statistics. So this is Z value, Wilcoxon signed rank value is -6.520, and this is asymptotic two-tailed highly significant. This is a p value for Wilcoxon signed rank test. And again, this is a treatment group, and this is a control group. You can see below this treatment group, again, Wilcoxon signed rank test. This is a rank, no need to like see it. And you have to see test statistics. And then you can see this is total WHO quality of life minus baseline and 3 month. Then you can see, okay, this is also highly significant. Same as paired T test. Now what happened? We have to calculate mean and like median and IQR within. So we have already like calculate for this. Again, we can calculate within group median and IQR. Okay, so we have to click here, because we have already separated this, split this file already. So for median IQR, we have to separate. So click here, analyze, then descriptive statistics, then frequency. I have to click frequency button. Then I click here, analyze, descriptive and frequency. Then because this is for BMI, I have to click, I have to remove, click here, and then click this button, arrow left. And then I know that I want this total quality of WHO life baseline. So I have to click here, and then I want for this total WHO quality of life 3 months median and IQR. Then statistics, I have to click on this statistics from here. Then I have already quartile and minimum maximum I have already checked in percentile value and dispersion. And then I have central tendency, I have click on median. Click continue, then click OK. So according to group, treatment group, for baseline and 3 month median IQR, I have already explained you, and control in control group. They can write my, these are the highly significant difference. Now I will take only 10 minutes, then I will explain about one-way ANOVA. So I have, for that, what I have to do, I have to choose, because in one-way ANOVA, there is more than 2 groups. So in which is there any significant difference of 3-month WHO quality of life score age per religions of subjects? Because religions of subject, hey, I think in my data sheet, I have to see, I have to click here, then I have to see my data sheet, and I see here religion is more than 2 group. This is a religion, Hindu, Sikh, Christian, Muslim. So it means this is a more than 2 group. So I, first of all, I have to I have to give code to religion. Then I can analyze. Otherwise, I cannot analyze. So it's a simple way. I have already told you simple way. So just click here on weight nearby this religion. Right click on paid, then insert variable. Click on insert variable. Then I want to give, and you have to like you data sheet, Excel sheet, Hindu 1, you have to like write down religion code Hindu 1, Sikh 2, Christian 3, and Muslim 4. I have to check how many Christian and Muslim, how many Hindu and Sikh, I have to check. So I want to give code. So you know, when I gave code to treatment and control, it is very easy because treatment and control are separated. Upper part is treatment, lower part is control. So it's very easy, 1 and 2. But what happened? I have to do manual entry. Yes, I have to do manual entry. So suppose I want to give Hindu is 1. So I have to type 1 here, Sikh 2, Sikh 2, Sikh 2. It will take time because I have 120 patients. And shortcut method, I have to do what I have to do. I have to click on religion button here. I have to select it. Then right click on this. Okay. Right click on paid. Then sort ascending or sort descending. So whatever you want, you can choose. I want to choose sort ascending. Click here. Then there are some missing values. You can see there are some missing value. So, okay, I have to check my performa. There is any relation or not. So if there is like I have entered in my performa, then I have to enter for these patient's name. You can see patient's name, then I can like check my performa, then I can enter. Otherwise, if I don't know, then leave it. There is no problem. Then I can give Hindu is 1. So please give 1 and then control and C and okay, it's copy, then shift and down arrow, and you have to, where is Muslim? Okay, Hindu is here. Very good. So control and V. Very good. Then Muslim, I want to give 2. Okay, Muslim 2. So just give 2. Then click anywhere else. Then again click, you have to click here. Then control C and then shift and down arrow. Then I have give Muslim 2. Okay, control V. I want to give Sikh as 3. Okay, I have changed my mind. Then just click on 3, then click and then Control C, and then so I have 3, and you can see here this is Christian here, and I want to see Christian, so I want to give 4. So I can easily 4, 4, 4, 4, 4, 4, 4, 4. Okay, then click here on this variable, okay, on 6, and then want to give name, religion code, religion code. And what I have given number, first I have to check frequency, then I can some do change. Why I want to do? Because there is a Christian and Muslim are like less in number, and Hindu and like Sikh are more in number. So I want to check this. So just, and you know that religion is a nominal variable. So I want to check frequency. I have to calculate frequency and percentage. So click here on analyze, descriptive statistics, frequency. Oh, frequency, there is some, okay, click here frequency, then remove these 2 variable. Okay, you can select and you can click on left arrow. Then where is religion code? This is religion code. You can put it here. I don't want these statistics because this is a nominal variable. So declick all these things, then continue, click OK, and then display frequency table. Because I didn't click here, and also I didn't click anywhere else in statistics chart format styles and bootstrap. So that dialog box will come. Okay, so you just click OK, and then you have to click display frequency and then click OK. So I see that 1 I have given Hindu, 2 Muslim, 3 Sikh, 4 Christian, and I see that this is 4, only 4 or 5 is missing. And you have to take valid percentage, as I told you yesterday. Don't rely on percentage, because there are some missing values, 5. So 5 is also coming here. So it's like this percentage include these 5 number. But I know that I have to calculate percentage from 115, because this 5 is missing. So always this valid percentage calculated from 115. So please rely on this valid percentage. Don't rely every time percentage only. And I know that 1 is like sufficient, 56 Hindu, 2 is Muslim, 17, 3 is Sikh, and 4 is 8. So I want to combine this 17 and 8, okay, just for fun. So how I combined this 17 and 8, like Muslim and Christian, no need to. I have given code to Christian 4. So just I have to give them to 2. So it's okay, no problem. So in data sheet, click here data view, then just give code to 2. So 2 code for Muslim and 2 code for Christian. Then I want to decode it, because otherwise I forgot. After some time, I will forget after some time. So I have to click on religion code here. So it's automatically come up. It's a like shortcut method. This is a religion code. Then this is value. Here is a value. And so click here, like here. And right side, you have to click, and this is value. So I have given 1 for Hindu. Click here only for 5 minutes. I will take not more than 5 minutes. And 2, I have given Muslim and Christian. And 3, just for only just coding, 3 for Sikh. Okay. And then 8. And okay. So I know that there are, according to religion, I have to check quality of life. So according to religion, religion has 3 codes. This is a nominal variable, 3 category. And my dependent variable is quality of life, 3 months quality of life. That is a quantitative variable. So I have to check that slide, which test I have to use. If the quality of life 3 months is normally distributed, then I have to go for ANOVA test, one-way ANOVA, with the multiple comparison. Otherwise, I have to go for Kruskal-Wallis test with the multiple comparison. So for ANOVA, I have to click before I have to already split file. So I have to remove split file. So click here on data, then come on split file, then click, and then analyze all cases. Please remember this. Split file only for Petty test or Wilcoxon. Otherwise, I have to use analyze all data. Click here, then OK. Then use this. Again, you have to click analyze and compare mean, and then one-way ANOVA. Okay, you have to click on one-way ANOVA. This window will pop up, and I have to click on the religion code here. You know that religion, Hindu, Muslim, Sikh, Isai, in alphabets, they already gone from here. So I have to give code to any variable, each variable. So religion code I have to click, and then in factor I have to bring this religion code. So whatever independent variable, you have to bring it in factor. So click here, it automatically come. There is no need to grouping it. And in dependent list, I want to check total quality of life 3 months. So I have to click here, and then okay, very good. After that, there are some other options: contrast, post hoc, option, and bootstrap. Bootstrap, there is no need of bootstrap. Then please click on option button, click here, then it's a descriptive. So you have to statistics, one-way ANOVA option, statistics, descriptive, you have to click descriptive, and then you have to click homogeneity of variance test. I will explain you what the benefit of this. So you have to click this, and no need to other like mean plot and other things, no need to, just descriptive and homogeneity of variance test. And click, this is confidence interval. Every time we have to take 95%, you can increase it 99, okay, and 99.9, but usually we are taking 95%. So this is 0.95, and click here, continue. Then you have to use, because post hoc analysis. So you have to use, because there are 3 groups. And if I don't use this, don't click this post hoc analysis. This is a post hoc analysis, multiple comparison. Usually I use this Bonferroni correction if equal variance assumed. And if equal variance not assumed, I will check this Dunate. So whatever you want to do, like check, you can check. Shidak you can use, Taki you can use. These are most popular. For equal variance assumed and not equal variance assumed, you can use, I prefer this Donut T3. Okay. So suppose I don't want to check this. Okay. And I just continue and click OK. This window will come. So this is descriptive statistics of one way ANOVA. Total quality of life 3 months, Hindu 53, Muslim and Christian 25, Sikh 34, total 112. So like some are missing, as I told you that, and this is a mean of these separately and standard deviation. No need to all these three, all these things. You can take minimum and maximum from here. Then you can see that is this is a test of homogeneity of variance. So you have to take based on mean. Always you have to take based on mean. Okay. So this is, and it p-value, this homogeneity of 11 statistics, p-value same as a t-test will come greater than 0.05. So I have to use post hoc analysis for Bonferroni and Sidax, equal variance assumed. If it will come less than 0.05, then I have to use Dunnet test. Okay. Then you can see here, this is ANOVA table, and this is like sum of square and degree of freedom, and this is a bit within group and between group. This is a like between group, and this is a within group. So how it's a number of group minus one. The number of group is a Hindu, Muslim and Christian and Sikh. So this is a degree of freedom 3 minus 1, that is a 2. And this is a within of group. Within of group means total number of observation, that is a 112 minus number of group. So how many number of group? 3 number of group. So total observation 112 minus 3. There are 3 group: Hindu, Muslim and Christian and Sikh. So you have to minus 3, that is a 109. And this is a significant. This is a F value and this is a significant. So the according to Hindu, Muslim and Sikh and Christian, something like we have combined Muslim and Christian. So at 3-month follow-up, the quality of life are equal, comparable. There is no significant difference that, okay? There is no significant difference because this p-value told. Sometimes what happened, if this p-value comes significant less than 0.05, so ANOVA, the null hypothesis of ANOVA is like mean of Hindu is equal to null hypothesis. Mean of total quality of life at 3 months is equal to Muslim and Christian group is equal to Sikh group. That is a null hypothesis. And alternate hypothesis, at least 2 group. At least 2 group, there is a significant difference in mean at least between 2 group. Maybe Hindu or Muslim and Christian, or maybe Hindu and Sikh, or maybe Muslim and Sikh, or maybe all Muslim and Sikh and Christian, and like Sikh and Muslim and Sikh and Hindu. So for this we have to apply like post hoc analysis. So this is not coming significant, but I want to like explain what is post hoc analysis. Click here analysis, then click on compare means, then ANOVA again, then we have already selected, then click post hoc. You know that it's a equal variance assumed because the homogeneity of variance is coming non-significant. So I have to click Bonferroni test. Otherwise, I have to click Dunnet T3. So Bonferroni, it's a most popular test, Bonferroni post hoc analysis. Click continue, then click OK. So what's the difference between these two? These are similar. Three things are similar. 3 box tables are similar. But what happened here? if this p value will come, okay, when like tomorrow or next day tomorrow I will explain if there is any p value. It will give only 1 minute. So you can see in which group this p value comes. So you can see here, this is a Hindu versus Muslim and Christian, and this is a significant p value, adjusted p value. This is a Bonferroni corrected p value, and this is this much. So it's also because this is not significant. So all things come non-significant. Otherwise, you can see like at least one or two value will like come significant. And Hindu and Sikh, comparison of Hindu and Sikh, you can see, okay, comparable. It means their mean difference is very less. Only one. This is a mean difference. This is a standard error of mean difference. And this is 95% confidence interval of a mean difference. You can see lower bound and upper bound. Now, you can see here Hindu and like group 1, and this is a group 2. This is p value adjusted. So again, 2 and 1, this is same p value here, 0.162. And then you can see 1, 2 and 3 group. This is a Sikh, 2 and 3. You can see here p value is 0.324. It means the third month quality of life is like comparable. There is no significant difference according to religion. And only for like I will take your 2 minutes. Suppose if data is not normally distributed, total WHO quality of life is not normally distributed, then what we have to do? We have to use non-parametric test. Mawali kahin ka or sirfira, or then Mr. Wilcoxon kindly see fried rice. So for ANOVA test, I have to use Kruskal Wallis test. So how I have to use? I have to click analyze. Then I have to click non-parametric. All non-parametric tests are here. Very good. It's like beauty of SPSS. Then I have to click legacy box. Then there is a K independent sample, because I know that Hindu, Muslim, and then Sikh are all are unrelated, like male or female. So I have to click this K independent sample. Then this dialog box come, test for several independent samples. Then this is because I know that this is, I want to check for religion code, religion. So I have to click here on religion, grouping variable. This is arrow. I bring this religion code into grouping variable, click here, and then I have to define range. So I have to click here. In ANOVA test, there is no defined range, but here. So because I have given code minimum 1 to code maximum 3, sorry 3. So okay, so I have to type in minimum 1 and maximum 3. I have to give code to 1 and 3. So click continue. Then where is my 3-month quality of life? Here. Then I have to click here, and then in test variable I have to bring this variable here. So I have to click this arrow. And you can see here test type, there is a default Kruskal Wallis test. There is a default. This is a for multiple group. If data is not normally distributed, then I have to click OK. Then what I have to see, again, I like request you that don't use this rank. We have to use mean, median, and IQR. And this is Kruskal Wallis value. This is degree of freedom. This is also asymptotic significant p value. So it's a greater than 0.05. This is a Kruskal Wallis test. Grouping variable religion, it's also not significant. But the difficulty is here. In ANOVA test, the p value was not did not come significant. But after that, we perform multiple comparison. But the problem is here in Kruskal Wallis that if p value will not come significant, there is no need of performing post hoc analysis. So don't worry. Tomorrow I will show you with significant p value in ANOVA and Kruskal Wallis. Okay, then you will get post hoc analysis. Then you can get difference. Okay, how to interpret data when the p value or result will come significant. So how to interpret the data in ANOVA and Kruskal valleys. So I like a little bit example, or like first 5 minutes I will give you demo on this. Okay, now I want to save my results in a Word file. So this is on below this transform. This is button of like paper like button, you can see, and there is a green arrow. You have to click here. I think you remember now. And this window export output will come. And I told you that in objects to export, you have to click all visible here. So you have, please don't like use all. Okay, suppose you use all. There is no problem. You can use all. Okay, so today I will use all. So what's the difference between two? We will see. Then click here, change option, and please, okay, shrink. Okay, shrink. So it's it's easy for me to see all these results like in fit to like in a page. Okay, A4 page. Then click continue. Then I want to change it because I have already saved this t-test 27 yesterday. So I have to click here, and then I want to change it today, like ANOVA, okay, ANOVA test. Then click OK. So I choose this object to export all. So what's the difference between this? Okay, and yesterday I choose all visible. So click OK. My result saved. So click minimize it, then again minimize. This is Excel sheet. I have given code, and this is my ANOVA test value. So just click here. I want to see what's the difference between that and this. You will get this much. Okay. So if you want that, this is the difference between this. You will get this table if you click all, and this is no need of this. No need of this, because for a statistician and for like a researcher, there is no need of this. So I have to click here, delete it. I have to delete it. So I told you that you have to select or like all, select all, not all only. Okay. So like all visible, you have to select all visible. So this is demo on parametric and non-parametric.